Hi folks, we're going to take a look at page 378, number 17, the challenge question to the last homework. Okay, so they give us this information about A, B, and C. So first of all, we see that A plus B plus C is equal to the 0 vector. So essentially, recall that that's telling us that if these three vectors add up to 0, that they're in equilibrium. Okay, so three vectors, they should form a closed triangle. Okay, and they want us to determine the value of this expression given the magnitudes of each of the three vectors. Okay, now here, in order to determine these particular individual expressions, well, we already have the magnitudes of the two vectors, so we're going to need the angle between them. So this is where I'm going to use this information here. I know that if I draw A plus B plus C, so if I just randomly draw A, which has a magnitude of 1, and B, which is a magnitude double of that, and C, will be the longest side, closes off the triangle, so 1, 2, 3. Okay, what I can do is find the angles inside this triangle to help me determine the angles between the vectors. Now I'm going to start with this angle here, okay, which I'll call theta. Okay, so this will be the angle between these two vectors placed tip to tail. Of course, if I want to find what's officially known as the angle between them, I'm just going to have to move this over, okay, and take the supplementary angle to get them tail to tail. Okay, so let's go ahead and do this here. So this is just, well, that's an easy cosine law. So here, cos inverse of, so here the opposite is 3, so 3 squared minus 2 squared minus 1 squared over negative 2 times 1. Okay, and let's get our calculator out here. Okay, so cos inverse. Maybe as I'm doing this, you might try to think of what intuitively the answer should be. Okay, so here 3 squared is 9, minus 4 minus 1, okay, divided by negative 2 times 1. And here we get, 180. Okay. Now notice here how I just randomly drew, three vectors in equilibrium with a shortest, a medium length one, and a longest one. Okay, but now we realize that this picture, we can be a little more precise. That it looks like we have an angle going from the one with magnitude 1. Then I'm adding to that tip to tail. This angle is going to be 180. So here I have my vector of size 2. And then I add to the tip of that one. Okay, let's add it on top. The vector of size 3. So it takes me back to where I started from. So imagine this being on top of that 1 plus 2 plus 3, back to where I started from, in equilibrium. So this is what these three vectors actually look like. So again, if I take vector 2 and I move it to the to the tail of vector 1, I see that the angle between them is 0. They're in the same direction. Okay, so what I'll call, I don't know, phi1, okay, is the angle between vectors 1 and 2 is going to be 0 degrees. And then if I take vector 3 and I move it to the tail of vector 1, we see that the angle is going to be 180. They're in opposite directions. Same thing to vector 2 in the other direction. So phi2 between the 1 and 3 is equal to 180. And then phi3, I'll call the vector between 2 and 3, is also 180. Okay, so now I can go back and solve the, evaluate this expression. So I have A dot B is equal to magnitude of A times magnitude of B times cosine of the angle between A and B was 0 degrees, plus, now the second one is magnitude of A times magnitude of C times cosine 180, plus the last one, magnitude of B times magnitude of C times, again, cos 180. Okay, and now this becomes very easy to solve because this is just 1 times 2 times cosine 0, which is just 1. So we get 2 minus 1 times 3 is 3. Cosine of 180 is negative 1. Oh, sorry, that's where the minus came from. I guess I was thinking ahead. Minus 3, and then here 2 times 3 is 6, times cosine 180 negative 1, so minus 6. So here 2 minus 3 negative 1, minus 6 negative 7. and there's our final answer. Okay, now it just so happened that our diagram really simplified because it turned out that all these vectors are parallel. But if that had not been the case, this is what I would have done. I would have found this angle here to help me determine the angle between vectors A and B. I would have found that angle there to help me determine the angle between A and C, and this angle here to help me determine the angle between B and C. Okay, recall these would not have been the angles between the vectors, but they would have all been supplementary to them. Okay, that's it for this one.